Why time flows one way? Why do we remember the past, but never the future? It's one of the biggest mysteries in physics. We see shattered glass on the floor, but never watch it jump back into shape. We age, we burn fuel, we forget, but we never reverse it. Everything around us points toward a single direction of time. But what if that arrow of time isn't written into the universe itself, but into us? In this video, we re-exploring Carlo Rovelli's groundbreaking idea that the past's low entropy might be a trick of perspective, ours. You'll see how our interactions shape time's direction, what that says about the cosmos, and why it could change how we understand reality itself. The arrow's illusion. We all live with time's arrow. You can feel it in your bones, aging, decay, memories that only look backward. But here's the strange thing, the fundamental laws of physics don't actually care which way time flows. Whether it's Newton's laws, Maxwell's equations, or even quantum mechanics. Most of these rules work the same forward or backward. So why does everything we experience, from the heat of morning coffee cooling down to the entire evolution of life, unfold in just one direction? The traditional answer has been because the universe started in a low entropy state. Entropy, in simple terms, is a measure of disorder. The second law of thermodynamics tells us that in an isolated system, entropy tends to increase. So if we look back in time, things must have been more ordered, more pristine, until we reach the beginning, a kind of perfect cosmic seed. Physicists like Roger Penrose have proposed ideas like the Weyl curvature hypothesis, which says that the universe's Big Bang had a very special, smooth geometric structure with minimal entropy. Others, like Sean Carroll, suggest that cosmic inflation and multiverse models might explain why our universe began in such an improbable state. But here's the catch. Those are just explanations stacked on more assumptions. Why should the universe begin in a special state at all? This is where Rovelli flips the script. Instead of assuming the universe was born special, he suggests that our definition of low entropy is based on how we interact with the universe. In other words, maybe the universe wasn't sabbath unusually ordered in the past. We just perceive it that way because of how we observe it. Imagine trying to describe the state of a sandcastle without ever touching it, only seeing shadows on the wall. You'd build your whole understanding based on a limited, coarse picture. And that's what Rovelli says we're doing with the past. We're reinterpreting it using a certain kind of coarse graining, which means we're picking and choosing what counts as macroscopic order. And that, in turn, determines whether we think entropy is increasing or not. Time's arrow may not be a fundamental feature of the cosmos. It might be a reflection of the limited, yet structured way we interact with it. Seeing time through filters. Rovelli's idea hinges on something called coarse graining, which sounds technical, but is actually pretty intuitive. When we describe a messy system, like a gas in a box, we don't track every molecule. We just talk about its temperature, pressure, or volume. That simplification is coarse graining. We reduce infinite microscopic detail into a few macroscopic variables that matter to us. Here's the twist. Different coarse grainings can make the same system look completely different. Rovelli argues that for any complex system, like the entire universe, there exists some coarse graining that makes entropy increase in one time direction, and another that makes it increase in the opposite direction. This means that the idea of past low entropy might not be an objective feature of the universe at all. Instead, it's based on how we, organisms, tools, observers, happen to interact with reality. And our interactions define which macroscopic observables we care about. That's where the arrow of time comes from, not from the universe, but from us. To make this concrete, Rovelli uses the metaphor of balls in a box. Say you have a bunch of colored balls bouncing around in a container. You choose to group the balls that were once on the left side and track their average position. You'll see entropy increase as they spread out. But if you instead group the balls that will be on the left side at the end of the simulation, you'll see entropy decrease. Same exact motion, different interpretation. The kicker is this: your choice of which balls to track, that's your interaction. That's your definition of what matters. In our world, our senses and instruments are tuned to certain macroscopic properties like heat, light, and memory traces. These observables naturally make the past look more ordered and the future more chaotic. So the arrow of time isn't universal. It's local. It emerges only when a system couples to the universe through time-oriented observables. Rovelli even imagines tiny observer subsystems that perceive time differently depending on how they rewired. And if they couple to different properties of the universe, their arrows of time might point in completely opposite directions. In other words, we see time flow forward because we evolved as creatures within a world that filters reality in that direction. But it didn't have to be that way. And that's a jaw-dropping shift in perspective. Entropy, life, and us. If Rovelli is right, then one profound question follows. Why do we, as observers, belong to a part of the universe that sees entropy rising toward the future? Why are we time-oriented subsystems? The answer might be as simple and as deep as evolution. Life requires order to build. It thrives on gradients, differences in temperature, light, chemistry. Earth, for instance, constantly receives high-frequency radiation from the sun and emits lower-frequency radiation back into space. That frequency difference creates an entropy flow that life exploits to grow, evolve, and learn. This setup, energy in, entropy out, is the thermodynamic foundation of life. So it's not surprising that intelligent, memory-forming organisms like us arise in regions of the universe where entropy is constantly being produced. Our brains literally run on this imbalance. Memories, culture, evolution, they all need time to move forward. We are shaped by and tuned to the thermodynamic arrow, but Rovelli takes it further. He suggests that our very notion of past and future depends on how we re-embedded in the universe. Just like we exist in places with liquid water, we exist in places where the universe looks time-asymmetric. But that might be more about us than about the universe itself. This flips a lot of our assumptions. Maybe the Big Bang wasn't some miraculous moment of extreme order. Maybe the universe isn't fine-tuned for time's arrow. Instead, maybe we were just filtering the cosmic mess through the narrow lens of human perception, using macroscopic observables that make entropy look low in the past. And the implications are staggering. It could mean that other observers, say artificial intelligences or alien life, might interpret time differently based on how they interact with their environment. Perhaps they remember the future and forget the past. Perhaps for them, entropy increases in reverse. And that's not science fiction. It's the natural consequence of Rovelli's framework. So what we think of as universal, aging, causality, memory, could be profoundly local, not just in space, but in informational terms. We don't live in a world where time flows forward. We live in a world where we perceive time flowing forward, because that's how our bodies, minds, and tools are wired to process reality. Time, in Rovelli's picture, is less like a river and more like a mirror, reflecting the direction we're built to see. Time may be personal. So what does all this mean? It means that time's arrow might not be a feature of the universe, but a feature of us. Our memories, our biology, even our sense of cause and effect could be rooted in the way we couple to the universe's chaos, filtering it through specific macroscopic observables. Carlo Rovelli's hypothesis doesn't just challenge physics, it challenges our place in the cosmos. Maybe the past isn't really special, maybe we are. Thanks for watching. If this blew your mind, share it with someone who still thinks time is a one-way street. See you in the next timeline.